Alright guys, so today we're going to be going through Leet Code question number 13, Roman to integer. And this question would be super simple if we could just add all the values together, but unfortunately that is not how Roman numerals work. So as you can see right here, if an I is placed before V or an X, it will make either 4 or 9 respectively, and you can see this is for all powers of 10 times 4 or 9. So how we would get around that, there's a couple different solutions. I'm going to show you a super straightforward one first, and then I will get into a quick one that does not take a lot of memory. So first we have to define what we will be adding to. So let total equal 0, start out as 0, create a for loop, I plus plus, and what we're going to be doing in here is going through a switch. So you should use a switch if you have a lot of if-else statements, because it's less code and it just looks cleaner. So we'll switch with SI as the value, and then we break it into cases. So in the case of capital I, then we go through these, and I will use some if-else statements inside of the case. So if SI plus 1, so if the next value in this array, or in the string, is equal to V, and what I'll do with that is total plus equals 4 and I plus plus. And we'll be doing the same thing for 10. So I will jump ahead. Here are all the different things that can happen in the case of I. So if the next value after I is V, then total will be plus equal 4, because I can be placed before V to make 4, and same with X and 9. And then we don't want to iterate through the variable again, so then we just increase our iterator by 1, and we just seemingly skip over the next V and X. And then we make the total is plus equal to 1. And then there's one more case that I want to show you. So the reason that we just add it there is because this value is never hit and then has to change, because we increase the iterator and they are never hit. So in this scenario, if there was a V right here, we would just add 4, then skip over it. And here I'll copy and paste the rest of it, and I'll show you how it works. Alright, so here's the full solution. And as you can see, for I, we have stuff that we do there. For X, there's X right there. We have stuff that we do in this. And for C, stuff that we do in this. And you can see they all kind of follow the exact same pattern, except for just magnitudes. So we have 2 zeros after all these, 1 0 after all these, and no zeros on these. So it's pretty copy and paste code, more or less. And here I'll run it. Passes all the cases, and submit it. And this one is pretty straightforward to see what we're doing. But what I like about the next solution that I'm going to show you is it takes up a lot less room. As you can see, this one takes 58 lines. Alright, so the first interesting thing about this new solution is this map. And it is just an object with key value pairs that will then compare all the values in the string of Roman numerals. We'll just compare it against this. So I will copy and paste the rest of the solution, and then I will get explaining it. Alright, so let's go through this function. So result, it's like total in the last one. It just accumulates all of the values, and it's what we return at the end. And then prev is pretty much just a running sample of what the previous value was. So we still iterate through every single item in S, or every single string in S. And here's where the magic happens. So we have prev, which is null at this point. So if prev is less than map si, then this gets ran, and I'll explain that with some examples later. And at the end of every single one, we let prev equal map si, result is plus equal to map si, and then we iterate through it again. So let's go through an example with MCM, which is equal to 1900. I'll show you how we get there. Alright, so we start out with M, and M, remember, is SI, and map SI is 1000 because of the key value pair. So we start out with 1000. This if statement doesn't get ran because prev is null. So prev and it doesn't even make it here. So start out with 1000. Prev is then stored as map SI, which is 1000, and result is equal to 1000. So then we add 1000 there. And then we loop through the next one, which is C. So prev is 1000. It's a round, it's true. It's a true 3 value. And is prev less than map SI? No, because map SI is C, or SI is C, and map SI is 100. So that doesn't get ran. Prev is now equal to 100. Result is now equal to 1100. Then we go through it again, and now we're on M. Alright, so now we loop through again. So we have M, which is SI, and we have map SI, which is 1000. So we'll loop through it again. Prev is true, prev is 100. Is prev less than map SI? In this case, yes. So with this, we have result equals result. So result equals 1100 minus prev. So then it's 1000. And then we have minus prev again. So then result is 900. And then at the very end of it, we say prev is equal to 1000, which even though we won't use it, then result is equal to result plus map mi plus equal. So that would give us 1900 at the end. And then we wouldn't loop through this again because it's all through, and we would return the result. So that's how this works. And I'll show you. We run it, accepted, submit it, and it beats the memory storage, but I don't think it's faster than the previous example. So that is Roman to integer. Thanks for watching.